Okay, this is the beginning of Chapter 7, Part 4, and we're going to start off with a few problems. So this first one is asking us for what is the change in gravitational potential energy. So we're looking to find the gravitational potential energy of a 50 kilogram person. So we know that is his mass, 50 kilograms. He's climbing a flight of stairs with a height of 3 meters. So we know h is 3 meters. And we're given a horizontal distance of 5 meters. Well, we know gravitational potential energy equals mgh. So this distance d, it was just extra information they gave us. We do not use it in the problem. So we have m being 50 kilograms times g is 9.8 meters per second squared times h is our 3 meters. Plug that in and you should get gravitational potential energy to be 1,470 joules. Okay, let's do another one. So in this one, you're in an airplane at 30,000 feet. So your height is 30,000 feet. You're asked to find the potential energy if you have a mass of 70 kilograms. So we know that potential energy equals mgh. And we know we need units of joules. We cannot get units of joules with feet. So I'm going to have to take 30,000 feet and convert it to meters. So I look at my conversion chart and I see in 1 meter I have 3.28 feet, which is going to give me 9146 meters. So therefore my potential energy is going to equal 70 kilograms times 9.8 meters per second squared times 9,146 meters. So my potential energy is 6.3 times 10 to the 6 joules. Okay, one more problem. You're asked to find the potential energy, so you're looking for potential energy of a 1,000 kilogram car. So the mass is 1,000 kilograms when it's on top of a 45 meter cliff. So your height is 45 meters. So potential energy equals mgh, which equals 1,000 kilograms times 9.8 meters per second squared times 45 meters. So your potential energy equals 4.4 times 10 to the 5th joules. Okay, if we talk for a minute about conservation of mechanical energy. So the sum of your gravitational potential energy and kinetic energy is conserved in some situations. That sum is called mechanical energy. So mechanical energy equals kinetic energy plus gravitational potential energy. When your frictional forces can be ignored and other non-gravitational forces do not perform any work, then the mechanical energy of the system does not change. Simplest example would be free fall. Any decrease in gravitational potential energy shows up as an increase in kinetic energy, or vice versa. You cannot create or destroy energy. You can only change it from one form to the next. Okay, let's look at a couple problems. So just before striking the ground, a 2 kilogram mass, so we have our mass is 2 kilograms, has 400 joules of kinetic energy. Kinetic energy equals 400 joules. If friction can be ignored, from what height was it dropped? So you're looking for the height. Well, you know that this mass is going to have both potential energy and kinetic energy because it's sitting up there and then it moves down to hit the ground. So just before striking the ground, we know this kinetic energy is a final kinetic energy. You are looking for an initial height. From what height was it dropped? So your final height is going to be 0 because it hits the ground. Your initial velocity would also be 0 because it's just sitting there. It hasn't moved yet. So with our conservation of mechanical energy, we know that the kinetic energy initially plus the potential energy finally has to equal the kinetic energy, this is initial, kinetic energy final plus my potential energy final. So basically initial equals final. So my kinetic energy initial is going to be my 1/2 mv initial squared plus my potential energy initial is mgh initial. That's going to equal my kinetic energy finally plus my final potential energy. Well, we said initial speed was 0, so that crosses out. The final height is 0, so that crosses out. So I have mg initial height equals my final kinetic energy, which I come over here, and in my list, that was 400 joules. So I'm looking for the initial height, so I'm going to divide both sides by mg, and I'm going to get my initial height equals 400 joules divided by 2 kilograms times 9.8 meters per second squared. So my initial height is 20.4 meters. Okay, one other problem. So we have a particle that has 37.5 joules of kinetic energy. So my kinetic energy is 37.5 joules. And it has 12.5 joules of gravitational potential energy is 12.5 joules. At one point during its fall from a tree to the ground. Okay, so these are all your initial values. Upon striking the ground, how much mechanical energy does the particle have? Okay, so conservation tells us that my kinetic energy initial plus my gravitational potential energy initial has to equal my kinetic energy final plus my gravitational potential energy finally. So my initial kinetic energy is 37.5 joules plus my gravitational potential energy initially is 12.5 joules. I am looking for my mechanical energy, which is kinetic energy plus gravitational potential energy. But once it lands up at the ground, my gravitational potential energy is 0 because my height will be 0. So therefore my mechanical energy is all kinetic energy. So my kinetic energy final is going to be 50 joules. Okay, this ends part 4 of chapter 7.